will work for you all the time. I like graphing this way. I don't have to do a table. I don't have to do a lot of calculations. I just graph it using what I'm given, okay? So let's look at, okay. Match the equation with its graph. Identify the slope and the y-intercept. So we have 3 graphs, and it may be a little bit hard to see right now because of not having your paper copies. You have to figure out which one of them. We're going to look at number 1. If I know that that is my y-intercept, is that a positive one or a negative one? Negative. It's a negative one. Do I have 2 graphs where the y-intercept is negative 1. Do you agree? B and C. Okay? Look at the slope. What is the slope in this one? 2. And it's a positive 2. I have 2 graphs. Both have a y-intercept equals negative 2. But are both lines a positive line?
No.
No. Which one is the y equals 2x minus 1? Which one is it going to be? Madison? B. Okay. Okay. So what is the slope of number 2? M equals what? Just looking here at the equation. Negative 1. Good. And the y-intercept equals what, Grace? What's the y-intercept of number 2? 2. Good. Oops, I made a mistake here. Which one of our graphs, A or C, has a y-intercept of 2? Which one, Shelby? A. Does it have a slope of a negative 1? It's a negative slope for sure, right? And so if I just go up and over, I've got a slope of negative 1. Do you agree?
Yes.
Because there's my slope. So this one has to be y equals negative x plus 2. Okay? Does number 3, is it C? I'm not going to just assume that they're correct. I'm going to go back and look at it again. M equals negative 2. What's the y-intercept in number 3? Going by the equation. Chase? What is the y-intercept in the equation for number 3?
Negative 1.
Negative 1. Good. Okay. So if I look at C, does it cross the y-axis at a negative 1, Marissa? Okay. Does it have a slope of negative 2, Annie? Yes or no, babe? And okay, that's good. That's the answer. If that's what you got, that's what I need to know. The way that you check that is you look at a set of, like you've got a crosshair. You've got a crosshair here. Do you agree? Okay. And I'm going to go up 1, 2, and over again to get a crosshair. Do you see this? And I can keep doing that all along that line. So does it have a slope of negative 2? Yes. Good. So this has to be y equals negative 2x minus 1. Okay? Now, we're going to be talking about linear equations of proportional relationships. We're graphing proportional relationships whenever we do the graph. And that's what one of the things that we're going to be looking at is, are the x and y proportional? In other words, every time is what that x changes, does y's change depend exactly, and is it the same? If we look at this one, at this point, we're going to find the slope of the y-intercept and graph each linear equation. So, we should have given you some graph paper. I think we got some. some further down. But we're gonna go ahead and do these the way they are, and I'll have somebody go over to that board over there, okay? Looking at A, I want you to write down what the slope is and what the y-intercept is for A. And I believe I now have you right there, Haley.
Yeah.
So look at the equation, write m equals what, and the y-intercept equals what? Good. 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 Okay. Do this. So what is the m? Kind of four. Okay, that is the stand for the slope, so m equals 44. And that is the y-intercept. What is the v? Okay, do you mind even, just so that. Yes. No, I'm sure I'll let somebody, but I don't know if I'm gonna let you, Madison. Okay, you can't always do it. You can't always answer the question. Yes. Yes. Okay. I'm not sure. Go back to this page. The M is the slope. And the B is the y-intercept. So what I had somebody else do, write the y equals mx plus b there. Now, the m was the slope, so write m above slope. And write b above y-intercept. So now, which one is your m? Yeah, so write that down. And what is the y-intercept for the b? But what kind of two is? Because this is in an addition statement, so you add opposite. Yeah, negative. So your y-intercept there has to be
No, it's just straighter.
okay. When I was walking around, I noticed that we've got a few that I went maybe a little bit too fast for. And so I had them take a look again and go back to the formula. Okay. This is my slope. And this is my y-intercept. So if it helps, come into this where it says to do this and write the letters above those so that you get the formula in your head, and then you match the words up with what they stand for. Okay? If that helps, you're welcome to do that. If you get ready to take a test, you can write it down. Speaking of formulas. Yeah. Let you start on one side. The very first session of your state assessment this year is going to have a resource page attached to it, like what I'm giving you right now. You know how they give you calculators? Well, now they're not only giving you calculators, they're also giving you formulas and conversion charts. The thing is, though, if you have not seen the formulas and conversion charts written the way they are, you may not know how to use them. I need the two right there. So I am giving you this now so that you can kind of start using it. I wish it would be nice if they had some of this stuff like this, the y equals mx plus b, but they don't. It's area and surface area, circumference, and volume. Okay? And then, of course, just your standard conversions.
There is a one, the y over
Where's it at? Oh, to find the slope, the change in y over the change in x, yeah. Okay, so they do give you that one. All right, and now your paper, you can go in and write because they don't tell you what each of these areas stand for. What figure would be base times height? Not a square. Not a square. Because the square is s squared. Down there, the third one down, s squared, that stands for square. Think of it as side squared. Base times height is the parallelogram. And length times width is the rectangle. And then as you look on down, we have, where's my extras? There they are. 1/2 base times height. What's that the formula for? Triangle. Good. Yeah, 1/2 times base times height is the triangle. 1/2 height times the base 1 plus base 2. What shape is that, Justin? Trapezoid. Good. The area pi r squared. What is that going to be, Ridley? That's your circle. Surface area. I don't know that one. I'd have to look it up. Surface areas, I need to look up.
I know the last one.
I know the 4 pi r squared. You know that one? What is that one? The circle. Okay. And then C stands for circumference of the circle. I know they give you the volume of a rectangle. Length times width times height. I'm not positive there on the base times, the big B times height on the volume on that one next one, because that's not the same thing as a, you wouldn't have the same thing as the parallel or trapezoid, not trapezoid, but parallelogram. I'm not sure what that is. And then we know the bottom one is slope. So, what? 4/3 pi r cubed is a circle. Okay, so that's one that I'm not familiar with.
I remember from my Excel.
From my Excel, good. Okay. I want you to keep this, just put it in your book. So then when you get to, you're doing stuff and you need to find the volume or the area of something, you've got a resource. Plus, if we start using it a little bit, it might help you remember them.
I think the 1/3 one is for a triangle.
Okay, it's something we're gonna have to figure out, okay? So we're gonna just put that away, but I felt like that's important. I need to get it out to you now. What I'm gonna do is I'm gonna laminate a few of those copies and put them with our manipulatives so that when it comes time for that state assessment, if you'd like to have a copy, but it won't have the labels because I can't put the labels on it. The copy would have to look exactly like what I just handed it to you, okay, before you started writing on it. Now, if you take one out before state assessment and you go through and you label them all so you have it, that's up to you. You could do that. But I can't give it to you that way, okay? And you can't bring it in already labeled. You'd have to label it when you started. And it's only on the first session, okay, that you'll even have that available to you. Okay, so I need somebody to go over to that graph board. First of all, what is the slope of number 1? What is M? And this would be what you need to do when you get ready to graph anything. And M is what type?
-4.
-4. And so in this case, Instead of having to write out y-intercept, what is the b? What does b? Miss Bryn? -2, good. We're gonna go ahead, did you guys go ahead and find it for, for b here? So, what is the m, what is the m in b? Cadence? 3 halves, okay, I agree with that. And what does b? What is b in this one? Molly? 5. How did you know that, Molly? So she says, on this one here, you've got to solve for y. And so y equals 3 halves x plus 5. You had to solve for y first. Okay? Which is why we've been doing solving for different things. It's the same thing. We're using it here now with this. Okay, I need somebody to go over to the board. I want somebody to go graph the first one over here for me. Gonna need a straight edge. Got it. Okay. G, you want to go graph? I think I got a marker over there still.
Yep.
Yeah. Okay, go ahead. So your slope is -4 and your y-intercept is -2.
Okay. Okay. I'm confused.
Okay.
I'm already confused. I don't know why I went up here.
No, that's perfect. Perfectly fine. Shelby, you want to go help him? Gee, it's okay.
Here you go. Do you want me to do it or just help him?
Go ahead. You can go ahead and do it, Shelby. Talk it through though, okay?
Okay, so since you want to do your y-intercept first, and since it's a -2, you go from 0 to 1, 2.
Tyler, I don't want to see that. I want you paying attention, please.
And then your slope is -4, so you go 1, 2, 3, 4. And then I didn't make it very big, but
Very good. Now, what are you going to have to do, though, to make sure that your graph is completely finished? I'm not going to make you do it right now, but you'd have to,
and then
yeah, number your x and y axis so that we know what your scale is. And you're also going to have to verify those 2 points that you've got drawn, okay? So you'd have to tell what they were,
Okay.
all right? Okay, you don't have to right now, but that's in a normal graph, that's what you would do, okay? That's what's going to be expected, okay? Can somebody go over and graph the second one? Marissa, you want to graph it? Go for it. Hey, you know what? I like this. I got some different people getting up and doing things, and I like that.
Wouldn't the b be a -5?
Okay.
Okay.
Can I just erase this?
Erase it, babe.
Can I just number this?
Pardon?
Can I number them?
Sure.
What?
Because it has to be.
I know.
So what you should have done is, the y-intercept was here. Okay, get what, 3? No, but it's 3. Y is at 3. See why you can't. There you go.
I tried.
Okay, Marissa, Olivia wants to come and help you. You're on track. You got the right idea, but we've got an error. Okay? Olivia, how about a different color? That way she can see what she did.
You would go up, y-intercept.
Have you
But
graphed?
that's the first thing that you want to do. So it would be 5. And then you
Might do that.
go
please.
up 3. And then over 2. And then that would be it. You know how about that? Okay, so the y-intercept, this line that goes up and down is 5. It says 5.
Okay. Can you see, okay, both of you girls, I want you to step aside for me. Can you guys see the difference in what Marissa graphed and what Olivia graphed? Okay? Whenever you go to do this, you start out with the y-intercept. Will you show the y-intercept of 5 there? And so you're on the y-axis, and you put a dot on the 5. Okay? Then the slope is a rise of 3, so you go up 3, and a run of 2 in the positive direction. That's why that blue line has to go towards the right. The minute that you see, if my slope is positive, if you see your line going to the left, you know you've made an error. Because that's a negative slope. And so you know right there you've got something wrong, okay? Remember the other day I said leave your slopes as improper fractions? This is why. Because I'm not going to change it to 1.5. I need to know I'm rising 3 and I'm going to run 2, okay? All right, good job. Thank you. Let's just find the slope here. What is the slope? What is the y-intercept of number 1? Michael, what's the slope here? What is the m? Tyler, what's the m? 3? Good. And so if I was wanting to know about the slope, I could write it that way, couldn't I? 3 over 1. Okay, so what is the y-intercept? Michael, can you tell me the y-intercept now? -7, good. Okay. I want somebody to, everybody's graphing on paper. Everybody's graphing this on paper. And then I want one person to go over to the whiteboard. Madison, I'll let you go this time. You're killing me. Graph paper, and I want you to graph this one. I want to know that you know how to graph it.
Yes?
Okay. -7. Put a dot. And then you go up 3. Yeah, use the lines, not the spaces. Don't count the spaces, count the lines. 1, 2, 3. And then go for 1. Yep, in the positive direction. So now your line is going to be those 2. Okay? Okay. Now, on your graphs, you have to be numbering your graphs when you're, so you might want to start numbering them now. Okay? Because when you go to turn it in tomorrow and it's not numbered, you're going to lose points. Okay? So make sure you're numbering them. That makes it easier for you. Yeah, good point. No, I didn't say you were turning that in, but you're going to have an assignment, and I don't want you practicing it without, because then when you do it for real, it's like practicing for basketball without a ball in your hand. Understand what I'm saying, Justin? Okay. Which one is it? Okay. What is your y-intercept? So go down to -7. No, right now, you graph your y-intercept.
Okay, you did like
-7. Okay. When you go to number, make sure they're not in. Okay, now, and what is your slope? So rise 3. 3. 1, 2, 3, and run down. Put it up. Draw a line. We'll see. Got it?
Mrs. Rakestraw,
Okay,
can I have 5 extra
Sure.
minutes? Okay.
I'm all for
We're
it.
almost done, but we're not there yet.
Okay, take a look at what Madison has drawn. Does your graph look like hers?
Yeah.
Everybody agree with it? Okay, what about the second one? What do I have to do for number 2 before I can do it? Before I can identify my slope and my y-intercept, what do I have to do? What do I have to do, Lindsay? I've got to add 1 to both sides, and Olivia, why am I doing that? Because I'm solving for y. Now I can identify my slope and my y-intercept. Joey, what's my slope?
Oh, your slope's -2/3.
And what's my y-intercept? Okay? Man, everybody, I like this. Who have I not had doing things? Ridley, would you like to do it over there? Everybody else is doing it on paper. I want number 2 graphed on paper. Why is it hard? Who said it's hard?
You did. That wasn't me. Yes, I do. Why are you pointing me?
Where's your reference? You do have that paper, right? I knew you did.
Yes.
I knew you did. Let's see it. Graph the second one. Number 2, graph.
How are you supposed to graph that one?
Oh shoot, what is it? Okay, so it'd be.
Remember, it's rise and run. So I'm going to rise how many? What's my numerator? Not what's the numerator? Excuse me. Stop. So I'm going to rise 2 and then run. How many is it? What's it on?
Oh.
Okay, let me see. See you grab. Where's your y-intercept? Put a dot on it first. Okay. Now, rise 2. Excuse me, rise 2 from that point. And then it's a negative. So you gotta run in the negative. Draw your line. Now, as I come around this time, I'm going to be looking for numbered axis. I'm going to look to see if this will be one that you would turn in. So I'm looking to make sure the axes are numbered, the points are labeled. Got to label your points. See, Bob? Where are we at? Here still? Okay, what's your slope? -2/3. So rise 2 and run -3. One of those numbers has to be a negative direction. So run in the -3. 1, 2, 3. Okay? Now you got your line. Good. Good. Okay, I want to see your axis number everything, and well, let me see that again. Okay, your y-intercept was this. Okay, no. And you went down to, I know, you're fine. That's fine. You do that. Put your arrows here and number everything.
You're not done.
Where are we at here? Yes. Yes. You did yours
What's left to do?
going down 3 and over, going down 2 and over 3.
You didn't know the axis.
I don't see
It was labeled.
It works.
Write your name.
He said.
That you did it.
I was labeled.
Was created by.
Get it numbered and
Created by Ridley.
label the points. Label the points.
Good, Chase.
Make sure you label the points. Okay, that is
Why'd you put 2 negative 11?
-3.
So 10.
Label the point then for what it really is.
Okay, I was looking on the What's that? Yeah.
There. Now you got it.
She would like it too.
Now smile and stand there. Do you like that one girl from Blue?
That
No, it's like right there.
Huh?
Why do like appears? Wait, it's like this, like.
You have it out. It's like, they're just like, oh, I didn't even know. I have slow reflexes. You like threw it on.
That's not how
I think it was like, are you like, you're like. Yeah.
So like, I wish I could
I want that. I don't know what that is.
What? It's like a button, I should know.
Okay, I know a lot of you have got this done, but I can't work with a student, okay? I want you to talk about what's going on with the rest of them so I can help this one real quick. Explain what you did and why.
Okay, so I did the y-intercept first, which was 1. So I went over 0, up 1. And then I went down 2 and over 3 to get the slope.
Why'd you go down?
Because it's a -2/3, so you rise -2, then go over 3.
Yeah, Ridley, why'd you go down to?
Just
Rise over run.
because the run is 3.
Rise over run.
So I rose -2 and I ran 3. And I did the line.
Why'd you 0, 1? Rise over run.
Because you ran 0 and rose 1.
Rise over run.
Okay,
Then
nice
you
job.
label it.
Nice job. Now, she does hers different than I do it, but is the line the same? Sure it is. There's nothing wrong with that, as long as you've got a negative line and your points are gonna be in the right place. The other thing that I've noticed is that some people have tried calling the second point, like in that case, they might have said it was 3 -2/3. That's not the point. -2/3 is the slope, it's not the point. So you want to actually calculate what that point is when you label those. In high school, I think the only other thing that we're not putting on that one right now is in high school, this is, say, their graph, okay? And on the graph, they also have to write in what the equation of that line was. So when the teacher goes to look at it, she knows y equals negative 3x plus 3. She doesn't have to get out the textbook to see what was graphed. This is what they graphed. So she already knows that. She also expects them to identify, well, what's the slope? Negative 3. What's the y-intercept? 3. And then graph from there. That's what she expects. She and all of the high school math teachers, this is what they expect. They also expect the axis numbered, and you can number it any way that you want, as long as they can tell what each part of that axis what each grid mark stands for. Okay. This one, the question was to identify what the x-intercept was. Okay. And I think this is one that had already been done. I actually had done. Yes.
Why is the point 1 3?
Because the point actually. Good question. Very good question. I think that's an error. There's no way that's 1 3. It would be 1. It should be 0. I agree. Okay. This graph also helps you to notice one thing. If we're talking about what the intercept is of y, if the y-intercept is a 3, the x is always going to be 0. We're looking at the y-intercept. The x value will always be 0. If we're looking at the x-intercept, the y value will be 0. Okay? Are they switching yet? She's ready? Okay. They are ready. Hang on here. Let me look. I think we're gonna. Yeah. We're gonna go ahead. Very small assignment. Math journal, page 82 only.
Okay, thank you.